Welcome to Student, a series of animated calculus videos that will help you prepare for the AP exam. These videos were made by students for students.
Particle motion on graphs by Gavin. Graphs of particle motion can give us the position, velocity, and acceleration. Using the graphs and their derivatives can also help us find the critical values and points of inflection. The graph of position. At x equals 0 is where the starting point is on this graph. At point B is where the function is farthest from 0 going forward or going right on a straight line graph. And point D is where the function is farthest from 0 going backwards or going left on a straight line graph. Points B and D are where velocity equals 0, and velocity is the slope of position or the derivative of position. This is where position has critical values. The graph of velocity, which is the derivative of position, gives us which way the particle is moving. Below the x-axis means the function is moving backwards or down, and above the x-axis is where the function is moving forward or up. On this graph, at time x equals 3 on the graph, the function equals 0. This is where the particle is stopped. The graph of position, velocity, and acceleration all go together, as the derivative of position is velocity and the derivative of velocity is acceleration, and integrating acceleration gives us velocity and integrating velocity gives us position. Here's a multiple choice question. The directions say, a particle moves along a straight line. The graph of the particle's position, x of t, at time t is shown above from 0 to 6. The graph has horizontal tangents at t equals 1 and t equals 5 and a point of inflection at t equals 2. For what values of t is the velocity of the particle increasing? So it's asking for where the velocity increases on a graph of position. So velocity increases when acceleration is positive or when position is concave up. The point of inflection at x equals 2 separates the concavity in a position graph. So that means that position is concave up from 0 to 2 and concave down from 2 to 6, which means that velocity is increasing from 0 to 2, which means that A is our answer. Here's a Frq question. The directions say that a particle moves along the x-axis so that the velocity at time t for 0 to 6 is given by a differentiable function v whose graph is shown above. The velocity is 0 at t equals 0, t equals 3, and t equals 5, and the graph has horizontal tangents at t equals 1 and t equals 4. The areas of the regions bounded by that t-axis and the graph of v on the intervals 0 to 3, 3 to 5, and 5 to 6 are 8, 3, and 2 respectively. At time t equals 0, the particle is at x equals negative 2. And for A, they ask us from 0 to 6, find both the time and position of the particle when the particle is furthest to the left. Justify your answer. So for part A, we have to look for endpoints and critical values as to where the furthest left is. And for the first endpoint at 0, they gave us that the position is negative 2. And using the integration of the areas above and below the x-axis, we can find out that at 6, the position is negative 9. And the critical values are where v equals 0, so at 3, which the position is negative 10, and at 5, which the position is negative 7. Using this, we can figure out that the furthest left is negative 10 at x equals 3. Part B, it asks for how many values of t where from 0 to 6 is the particle at x equals negative 8. Explain your reasoning. So since this function is differentiable, we can use the MVT and the past answers to answer this question. So the MVT and the answers gives us that x equals negative 8 3 times from 0 to 6. And the 3 times are from 0 to 3, it crosses from negative 2 to negative 10. From 3 to 5, where it crosses from negative 10 and negative 7. And from 5 to 6, which it crosses from negative 7 to negative 9. So that gives us 3 times that it crosses x equals negative 8 from 0 to 6. So part C is asking, on the interval 2 to 3, is the speed of the particle increasing or decreasing? Give a reason for your answer. So we are looking for velocity and acceleration, and from 2 to 3, the velocity is negative and the acceleration is increasing on the interval 2 to 3. And since the velocity and acceleration signs do not match, the speed is decreasing. And in part D, it asks, during what time intervals, if any, is the acceleration of the particle negative? Justify your answer. So on the graph of v of t, we are looking for the slope of the function. And so we are looking for when v of t slope is negative. And from 0 to 1 and 4 to 6 is when the velocity slope is negative, which means that the interval 0 to 1 and 4 to 6 is when a of t is negative, giving us our answer. And here's the guidelines and scoring for the Frq question. So for part A, you have to consider the endpoints and critical values, and you have to use integration to get the solution, and that would get you 3 points. For part B, finding the values of critical values and using that to find where x equals 8 and how you describe the motion gives you all 3 points. For part C, finding v of t and a of t finds us the answer, which would get you 1 point. And then for part D, the answer and the justification and finding derivative of the graph gets you 2 points on that. And that is Particle Motion on Graphs by Gavin Carlson. Thank you.